Hey everyone, and welcome to my channel. Today's explainer unpacks a genuinely staggering claim from a company called Subquadratic. We're looking at a brand new 12 million token AI model that supposedly slashes compute costs by 1,000-fold. I mean, in an industry where compute is literally the ultimate bottleneck, a claim like this, it has the potential to absolutely rewrite the rules of everything we know about artificial intelligence. So I want you to imagine something for a second. What if an AI could read your entire unedited code base, every single legal contract your company has ever signed, and 10 solid years of financial records, all in a single prompt? No searching, no summarizing, just holding all of that raw information in its memory at exactly the same time, ready to reason through it. That right there is the massive value proposition of extreme long context AI, and it's exactly what we're digging into today. Since we're dealing with some fairly advanced concepts today, here's our roadmap. We'll start with the attention bottleneck, then introduce subquadratic sparse attention, break down the actual benchmark data, look objectively at the controversy, is this a breakthrough or an AI Theranos, and finally explore if this means the end of RAG. Let's get into it.
Section 1, the attention bottleneck, hitting the invisible wall. To really appreciate this new solution, we have to first understand the massive mathematical roadblock that every major AI lab just keeps slamming into.
And that invisible wall is known as quadratic scaling. Standard transformer models understand language by comparing every single token against every other token. And sure, it's an incredibly effective way to understand context, but man, it comes with a brutal mathematical cost. It scales at O of n squared, meaning if you double the input length, the computational cost doesn't just double, it quadruples. If you scale your prompt from 10,000 tokens up to 1 million tokens, the compute cost skyrockets roughly 10,000 times. It's totally unsustainable. Because of this punishing scaling issue, models simply cannot cheaply hold entire documents in their head. So the entire AI industry was basically forced to build these clunky workarounds. Take a look at a standard retrieval augmented generation, or RAG, pipeline. We chunk documents into pieces, store them in vector databases, build systems to retrieve what we hope are the relevant snippets, and then ask the AI to piece those fragments together. It's a massive amount of scaffolding, built entirely around the fact that context is scarce and incredibly expensive. Which brings us to Section 2. Enter subquadratic sparse attention, the linear paradigm. This is where a 13-person Miami startup called Subquadratic enters the picture, emerging from stealth with $29 million in seed funding and a radically different architecture. And this really brilliantly illustrates their core breakthrough. Standard dense attention compares everything to everything, which gives us that horribly expensive quadratic curve. But subquadratic sparse attention, or SSA, works completely differently. Instead of computing every pair or relying on rigid fixed patterns, SSA dynamically learns which relationships actually matter based on the meaning of the content itself. And then it just ignores the rest. Now, the absolutely crucial point is this claim right here. Their architecture is linear all the way through. Why is that such a big deal? Well, other sparse attention systems out there use an indexer to select which tokens to pay attention to, but that indexer itself still scales quadratically. If your solution to expensive attention is an expensive attention selector, you haven't actually solved the problem, right? You've just moved it somewhere else. Subquadratic claims they've eliminated that quadratic math entirely end to end. All right, Section 3, breaking the benchmarks with SubQ 1.1 small. Let's look at the actual data from their June 2026 release, because the numbers they published are absolute showstoppers. Just look at the sheer scale of the efficiency here. At 1 million tokens, a single pass-through dense attention takes about 252 petaflops of compute. SSA does it in 3.9. That is a staggering 64 times reduction in compute for a single attention layer. And the crazy part is, the longer the context gets, the wider this efficiency gap becomes. And they're claiming this massive reduction doesn't destroy accuracy. Walk through this near-perfect long context retrieval data with me. This is the classic needle in a haystack test. At 1 and 2 million tokens, it hit 100% perfect retrieval. But look down at that 12 million token mark. The model maintained 98% accuracy, despite primarily being trained only on 1 million tokens. To pull that off at 12 million tokens, it was only attending to 0.13% of all possible token pairs. That's wild. The raw speed is equally impressive. When matched up against Flash Attention 2, which, by the way, is already the gold standard optimization used almost universally in production today, SSA runs an incredible 56 times faster at 1 million tokens on an NVIDIA H100 GPU. We're talking 966 milliseconds versus over 54,000. It's night and day. But retrieval is easy. Actual reasoning is hard. As we see on the Automation Bench finance test, sub-Q isn't just a retrieval trick. On this brutal, multi-step agentic business task where partial credit simply does not exist, sub-Q 1.1 small scored 13%. That sits remarkably close to the most powerful frontier models in the world, like GPT 5.5 at 18%, and it actively beats models like Sonnet 4.6. For a small, specialized model, holding its own here is a very big deal. Section 4, Breakthrough or AI Theranos, the community reaction. Now, in an industry deeply burned by overpromises, we have to impartially look at why the AI community is so fiercely divided on these claims. We can't just look at the shiny numbers without addressing the skepticism. Because if you scroll through the reaction boards, you're going to see two sharply contrasting camps. Some developers are calling it the biggest breakthrough since the Transformer, but others, they're literally calling it an AI Theranos. These reactions really perfectly capture the extreme polarity and skepticism surrounding this launch right now. And look, the critics have entirely valid points. First, there's the magic.dev parallel. Back in 2024, they raised $500 million on very similar 100 million token efficiency claims, but we've seen pretty limited real-world adoption since. Second, there were audit discrepancies. Early internal tests showed an 83% score on a benchmark, but the third-party app and verification only found 65.9%. Third, the technical papers were delayed, which obviously fueled doubt. And finally, the CTO confirmed this model is not actually built from scratch. It's an existing open-source model where the dense attention layers were essentially ripped out and replaced with SSA. While that's a completely practical choice for a startup, it definitely makes people cautious. Moving to Section 5, the end of RAG, a new software paradigm. Let's just assume for a moment that Subquadratic actually delivers on these claims in production. We need to explore exactly how this reshapes the downstream reality for software development, because the implications are truly massive. So the crucial takeaway here is that this linear workflow entirely bypasses the need for chunking, vector databases, and all those retrieval guessing games. Look at this new paradigm. Step 1, you load your entire unedited repository straight into the context window. Step 2, you prompt the model. That's it. It fundamentally changes how developers interact with their data by just entirely eliminating the RAG middleman. Removing that context scarcity unlocks genuine whole repository reasoning. It suddenly makes it economically feasible to dump a messy, decade-old monolith into an AI. You could ask for true, architecture-level refactoring across hundreds of files. You could get cross-file dependency tracing without ever clicking through a single folder. It unlocks long-horizon agentic coding that spans entire multi-day sprints. Plus, the dramatic cost reductions finally make it viable to run deep AI analysis on every single commit in your CI/CD pipeline. Which leaves us with this final, incredibly provocative question. Is the current architecture of enterprise AI, the vector databases, the orchestration layers, the chunking pipelines, is it all built around a bottleneck that simply no longer needs to exist? Because if Subquadratics is right, all that scaffolding we call RAG is essentially dead weight. The next few months of real-world developer testing will give us our answer. Thank you so much for joining me today. If you enjoyed this explainer and want to keep decoding the cutting edge of tech with me, please hit that like and subscribe button. I'll see you in the next one.